kilometers from the airport with two damaged aircraft engines. What is the connection between sea salt and this incident? The incident is considered one of the most successful emergency landings in civil aviation history. Preparation and departure. On the morning of April 13, 2010, Cathay Pacific Flight 780 was preparing for takeoff from Juanda International Airport, Surabaya, Indonesia, heading for Hong Kong. The Airbus A330, equipped with two Rolls-Royce engines, underwent a complete pre-flight inspection process according to aviation industry standards. Captain Malcolm Waters, with over 7,000 flight hours and more than 2,500 hours on this aircraft type, and First Officer David, with 4,000 flight hours of experience, were in charge of the flight. Technical checks from the fuselage and control system to the fuel system found no issues. The fuel from the previous flight was completely topped up, and safety procedures were confirmed. The refueling process was normal, and the fuel sample check in the beaker showed it was clear and clean. After completing all procedures, 309 passengers were allowed to board, and the cabin and baggage compartment were ready. The flight crew, consisting of 2 pilots and 11 flight attendants, prepared for the approximately 4-hour flight. The aircraft was pushed back from the gate, taxied, and lined up for takeoff on runway 28. The wind was light, visibility was good, and the temperature was 28 degrees Celsius. Not a single sign at this point foreshadowed the danger ahead. All systems were operating normally, from the engines and flight control system to the electronic monitoring equipment. The situation was completely normal, preparing for a standard air journey. But it was precisely these seemingly small details during the preparation phase that would lay the groundwork for the serious incident that occurred later. The aircraft began to accelerate, and 30 seconds later, the Airbus A330 gently left the ground, starting its journey toward Hong Kong. The hidden fuse for Cathay Pacific Flight 780, while everything on the ground followed standard procedures, a silent problem had begun to form. The refueling process at Surabaya Airport was not entirely straightforward. The fuel pipe system had just been refurbished, with the underground pipes replaced and sealed. During this process, heavy rain and water from surrounding lakes flooded the system, causing salt water to infiltrate the fuel. The fuel trucks still pumped fuel through the SAP filters, which are designed to remove water. But when these filters encountered salt, they began to disintegrate. Small fragments from the filter were released into the fuel, completely invisible to the naked eye and not triggering any warnings during standard pre-flight checks. This was a time bomb, undetected, not causing an immediate failure, but posing a serious risk to the entire engine system throughout the flight. The tiny, invisible SAP particles followed the fuel flow into the engines. As the aircraft accelerated and reached cruising altitude, these particles gradually accumulated and began to obstruct the normal operation of the fuel metering valve. They caused the valve to jam, making the engines fail to respond correctly to commands from the throttle levers. This was the root cause of all the severe issues that followed, turning a normal journey into a dual-engine emergency. No signs had appeared on the warning systems yet. The crew, ground engineers, and passengers were unaware of the danger. In reality, the plane had taken off with a potential hidden hazard, silently waiting to erupt on the way to Hong Kong. The first signs immediately after the Airbus A330 left the ground. The flight crew began monitoring the engine parameters. Just a few minutes later, engine number 2 began to show abnormal fluctuations in the engine pressure ratio, EPR, a key indicator that measures engine performance by comparing exhaust pressure to inlet air pressure. These variations were the first sign that the engine was not operating stably, although other parameters remained normal. The pilots immediately contacted the ground maintenance center to report and receive instructions. Engineers on the ground suggested performing checks, observing the engine's response to the throttle levers, but no immediate emergency solution could be applied. The crew was advised to continue the journey, monitor the parameters closely, and follow the procedures in the flight manual. In this context, the aircraft continued to fly at cruising altitude, but the danger was silently escalating. The small SAP particles from the contaminated fuel began to affect the fuel metering valve, making engine number 2 sensitive to throttle changes. Although no serious warnings had appeared, the EPR fluctuation was an early warning for a chain of more severe incidents about to occur. At this moment, everything on the outside was still normal, But with the crew's skill and experience, they recognized a potential problem brewing, ready to flare up at any time on the way to Hong Kong. Engine trouble escalates as Cathay Pacific Flight 780 maintained its cruising altitude. The initial problems in engine number 2 began to become more apparent. The ECAM electronic monitoring system continuously reported a control system fault on this engine, accompanied by a sluggish response to throttle input. The engine did not respond immediately to changes in thrust, making control more difficult, although other parameters were still within normal limits. The flight crew immediately contacted the ground maintenance center. The engineers listened to the information and advised the pilots to continue the journey to Hong Kong. They committed to replacing the faulty component immediately upon landing. The pilots followed the instructions, closely monitoring the parameters and performing procedures in the flight manual. But the situation did not improve, showing signs of worsening. Throughout the journey, the EPR fluctuations and engine control faults increased, creating a serious potential risk. The SAP particles in the fuel, which had disintegrated upon contact with salt water, began to affect the fuel metering valve, preventing the engine from receiving commands accurately. The flight crew continued to fly normally as instructed, but in reality, the danger was silently growing. The aircraft was nearing Hong Kong with one engine already showing signs of instability, ready to create an emergency that, if not handled correctly, could have severe consequences. Loss of both engines on approach to Hong Kong dashed as Cathay Pacific Flight 780 approached Hong Kong. About 80 kilometers from the airport, the situation suddenly became critical. Engine number 2 suddenly stalled, losing its ability to generate thrust. Immediately after, engine number 1 also failed to respond correctly to the throttle input. The flight crew realized this was an emergency situation and issued a mayday signal to air traffic control, requesting priority landing. The aircraft at this point had almost turned into a giant glider because the fuel metering valves, the critical components controlling the fuel flow into the engines, were clogged by SAP particles from the contaminated fuel. The valves could not respond to commands from the throttle, preventing the thrust from changing as the pilots intended. Any control input did not change the engine speed, turning the aircraft into an unresponsive mess. The flight crew immediately switched to the Airbus A330 emergency procedure, turning the engines off and on again, trying procedures with the APU auxiliary power unit, and checking the hydraulic and electrical systems. Despite maximum efforts, engine number 2 ran below idle speed, while engine number 1 only partially responded, not enough to control speed or maintain normal thrust. Everything now depended entirely on the skills of the 2 pilots, their ability to manually control the aircraft and use the backup systems. This was the most stressful phase of the flight, as both engines were virtually ineffective, placing the entire journey into a life-or-death emergency. High-speed emergency landing dash. After almost completely losing engine control, Captain Malcolm Waters was forced to fly the aircraft entirely manually, using the remaining controls to maintain direction and altitude. The aircraft was directed toward runway 07L at Hong Kong, but the thrust from engine number 1 was still stuck at a high level, causing the aircraft speed to exceed the safe limit for landing. The flight crew implemented all control measures, gradually reducing altitude, adjusting the approach angle, using the flaps and drag-inducing devices to slow down, while preparing for an emergency stop on the runway. Upon contact with the runway surface, the aircraft skidded more than 2,600 meters due to the high speed and remaining thrust, far exceeding the normal landing distance. The braking system worked to its maximum, but the temperature rose to an extreme level, with warnings displayed in the cockpit and smoke rising from the wheels. The procedure for preparing for touchdown and slowing down occurred simultaneously with controlling the aircraft's direction, ensuring avoidance of obstacles and maintaining the correct runway path. Finally, the aircraft stopped completely, safe in its position on the runway, although the brakes were overheated and the engine still had high thrust. This phase concluded the emergency landing, a testament to the crew's precise skills and reflexes, turning a near disaster into a successful outcome under severe emergency conditions. Investigation dash. Immediately after the aircraft stopped on the runway, the flight crew initiated the emergency evacuation procedure. All 309 passengers and 13 crew members safely left the aircraft. Using all available emergency exits and slides, while checking the cabin to ensure no one remained. This process was completed in just a few minutes, demonstrating the organization, procedures, and accurate reflexes of the flight crew in an extremely dangerous situation. After everyone was safe, the Air Accident Investigation Agency conducted technical analysis and collected evidence from the scene. The results determined that the direct cause of the incident was fuel contaminated with salt water, which caused the SAP filters to fail and the fuel metering valves in both engines to jam. When the valves jammed, the engines did not respond to throttle inputs, leading to the loss of thrust control, creating a situation where the aircraft nearly became a giant glider over the final leg. This incident became one of the most successful emergency landings in civil aviation history, demonstrating the precise control skills, crisis management, and synchronized coordination of the flight crew, from the captain to the cabin staff, under extremely high pressure and critical technical conditions. The lessons learned from this incident have changed fuel control and engine maintenance procedures across many international airlines,